If you've ever gotten a fracture, you would remember your doctor performing an X-ray to see the extent of the injury. The same idea also extends to MRIs and ultrasounds that help doctors see the health of our body without causing hurt or being invasive to arrive at a proper diagnosis. In the manufacturing world, similar testing methods are used to evaluate the health of structures and machines without causing harm to them. This is what we refer to as non-destructive examination or non-destructive testing. NDT is used to detect flaws, inconsistencies within structures or evaluate materials in a system without dismantling them. From motor vehicles to bridges, NDT finds its presence across a variety of structures. Importance of NDT is similar to the saying that prevention is better than cure. Early detections can help prevent the high costs of replacements or even accidents caused due to the component defects. Undetected faults can potentially cause serious harm to life and property. It is advisable to perform NDT during each construction phase. It is a lot more cost-effective to replace or repair materials at the testing stage than for companies to incur massive costs later on. There are various NDT techniques that stem from the four main criteria of material type, defect size, defect location. Let's begin with the visual examination method. The visual examination technique is often the first step in the NDT process. It looks at surface defects like spatter, excessive buildup, heat distortion, undercutting, and poor penetration to help decide the level of acceptability of the material used. This can either be performed directly with our eyes or indirectly with the help of visual aid. Some common tools for examination include flashlights, tape measures, magnifying glass, fillet gauges, etc. Magnetic particle examination. Magnetic particle examination is used to look at surface or subsurface discontinuities on metallic surfaces of thickness 4 mm to 6 mm that can be easily magnetized. In this method, a magnetic flux is created to detect flaws in the specimen using an electromagnet. The magnetic flux lines running along the surface will deviate on encountering a crack, and this defect can be detected and analyzed. Liquid penetrant examination is another NDT method that makes use of fluorescent dye to highlight surface flaws on parts and surfaces that may not be visible. The liquid dye is allowed to flow into narrow space without any gravitational help. Once the dye is given enough time to soak, it is combined with the developer to see the discontinuities in the surface that will appear in the color of the penetrant dye. Liquid penetration examination is among the most cost-effective and easy NDT techniques to perform, and therefore finds widespread use in various industries. Radiographic examination. Remember the X-ray example? Well, radiographic examination is another NDT method which is basically an X-ray of a structure. It is used to reveal flaws that exist deep within a component by using X-rays or gamma rays. In this method, the X-ray waves are made to pass through the material, and as it does, so it forms a negative image on the film, revealing the inconsistencies. Ultrasonic examination as an approach not only determines inconsistencies in the component, it also points out the size and location of the said inconsistencies using high-frequency sound waves. There are three main components to ultrasonic examination: a pulsing source and receiver, a transducer, and a data visualization mode. Sound waves are made to travel through the object. If there are any inconsistencies, they will produce a reflective effect that will send energy back to the receiver. This will then be converted into visual data to correspond the findings. Lastly, we have leak examination, which can be performed with liquids or gases. It is used in either pressurized or evacuated components to detect and locate leaks and also to measure amount of fluid leakage. It works by locating the point of leakage, measuring the leakage rate, and then assessing if that falls under the permissible limits or if it is likely to cause issues in the future. In the pressure decay examination, for example, the product is attached to the leak examination system, which is filled with air. Once the pressure has been optimized, it is allowed to settle. Any decrease in air pressure over a given time will point towards a leak. Through this video, we've understood the mechanism of an NDT that helps examine components for faults and defects, and the 6 different techniques that can be employed to perform this, like visual examination technique, magnetic particle examination, liquid penetrant examination, radiographic examination, ultrasonic examination, leak examination.